Hello everyone, today we are going to go over chapter 3.5 of the volume 1 OpenStax calculus textbook. Today I'm going to introduce the theorem of the derivatives of sine and cosine, and then we're going to go over a couple of relatively easy problems. Okay, so the derivative of sine and cosine x. The derivative of the sine function is the cosine function, and the derivative of the cosine function is negative sine. So you can go ahead and read in this book to see why the proof is, but basically it is right over here. The one that's not dotted is going to be the sine function. Basically, when you are calculating the derivative from like this point at 1/2 pi, it's at 1, but at that part it's at a trajectory, so there's no movement going on, so the derivative of that is going to be 0. Meanwhile, in the middle of the sine curve, it's going at a rate of 1, which is why when you find the derivative of 0 or sine pi, the derivative is going to be 1 or -1, depending on the direction of where it's traveling. Okay, so we're going to go ahead and start on one problem, example 3.39. And in this problem, it's asking us to find the derivative of the function f of x is equal to fx cubed sine x. So I don't know if you can see it, but there is two functions in this function. And so then we know that we can use chain rule. And remember, the chain rule is the first times the derivative of the second plus the second times the derivative of the first function. And that's how you get f prime of x. So let's go ahead and set a equal to 5x cubed and b equal to sine x. Oops. Okay. So what's the derivative of a? Well, this is going to be the power rule, which is going to be 15x squared. Meanwhile, we just learned that the derivative of sine x is going to be cosine x. Therefore, the derivative of this is going to be the first 5x cubed times times cosine x, which is the second, plus the second times the derivative of the first. And that's going to be your final answer. Okay. Now, moving on, we now are going to look at the derivative of the tangent function. So the derivative of the tangent function is secant squared x. I'm actually just going to go ahead and show you the table right here. The derivative of tan x is secant squared x. The derivative of cotangent x is negative cosecant squared x. Derivative of secant x is secant x tangent x. And the derivative of cosecant x is equal to negative cosecant x cotangent x. So when you are approaching these problems, what I would recommend is doing some problems like looking at these like tables of derivatives. So go ahead and look at these 4, and then like whenever you're practicing, go ahead and look back over here at this theorem about the derivatives of sine and cosine. And then the more that you like refer to it, I feel like eventually you kind of embed it into your brain, like, oh yeah, the derivative of sine x is cosine x. And it's like, it's basically second nature at that point. since you've practiced it so much, you know. So yeah, I'm gonna go ahead and we can try one. But I think we're almost out of time. So we want to find, we're gonna do 3.29. Okay. We want to find the derivative of 2 tangent x minus 3 cotangent x. Okay. So let's go ahead and just focus on the trigonometric functions. Don't worry about the 2, don't worry about the 3, don't worry about the minus sign. In fact, let's actually even rewrite this. Okay. So now let's refer to our knowledge. Let's look at this table here. What is the derivative of tan x? Secant squared x. So then it's going to be 2 secant squared x plus, what's the derivative of cotangent x? Negative cosecant squared x. So we're going to do negative 3 times negative cosecant squared x. Okay, now what? We're going to simplify this even further by getting rid of these negative points right there. So then our final answer is going to be negative secant squared x plus 3 cosecant squared x. And that is going to be the derivative of the function above. Okay, I think that's all we have time for today. Again, practice, guys. Have a good day.